Today I wanted to talk about some of the inspirations for my Æther idea. Okay, so another interesting man on my list of unknown physicists is Viktor Grebennikov. Viktor Grebennikov was the first one who used an asymmetric capacitor to actually give us the idea of an anti-gravity platform. I still don't know if it is anti-gravity or that it's just ion wind or static stuff, but what he did was asymmetric capacitors, and he used that to create a platform that supposedly flew. He's known for having moved huge rocks without using any tools that we use these days. So what he said is he knew the secrets of the Egyptians, of how the pyramids were built. Interesting stories. It's all from way back in the beginning of the last century, so I'm not sure if it's real, if it's stories, but it's definitely interesting to check out. Another physicist, some people think he's hoaxing, some people think he knows the trick to anti-gravity, some people think he knows free energy. His name is John Hutchison. John Hutchison. He's known for a small video clip where he supposedly makes bowling balls fly to the ceiling. So he used 3 Tesla coils and he was toying around with the frequencies and the amplitude and the voltage. I don't know what he did, but for some reason he made things fly, but he couldn't replicate what he did because he didn't know exactly what was happening. People on the internet are thinking it's a hoax. Other people on the internet are taking it seriously. I don't know, man. I don't know. It's definitely interesting to check out. So the next one on my list of unknown physicists, in theoretical physicists, this one is called Mehran Keshe. Mehran Keshe is known from the Keshe Foundation. Supposedly he talks about material being antimatter, matter, and dark matter, if I'm right. So he calls the proton a combination of antimatter, matter, and dark matter, if I'm right. And he claims to know how to cold fuse things, but I read his papers and they were mostly filled with text and not with calculations, and usually calculations help us calculate. So I don't know, he's definitely interesting to check out, but yeah, he was an inspiration in a certain point of time in my physics research. We get to Alan Lapoint. Alan Lapoint is known for the primer fields video on YouTube. Again, this video talks about a donut-shaped universe or donut-shaped ideas. What he did was having a ball magnet with a hole in it, and he found out that these ball-shaped magnetic fields, so if you have a magnet, imagine the bowl you use when you eat cereal. Usually has a shape like this. Normal bowl, you can eat cereal from it. I'm gonna draw this bottom here. You can go through the bowl. This ring here, the bottom ring and the top ring are north and south. So this can supposedly be north, this would be south, or vice versa. It doesn't matter. As long as there's a hole inside. He figured out that there are some forced domes inside, so he drew a dome here. He can show you in videos that this is actually happening. So there is a point in the middle where Æther can escape up with my arrow here, and it has a donut shape around it, and Æther flows inside and can only enter from this point or that point. So very interesting idea that man has. What I'm trying to say is definitely interesting to check out the primer fields. Then I read a book a long time ago of Konstatin Meyl. He wrote a book that's called Scalar Fields. He wrote it about Nikola Tesla and about some ways that Nikola Tesla supposedly transferred energy, and he called that using scalar fields. But very interesting to read his book because he got a lot of equations that really got me thinking, and a lot of ideas about the laws of electromagnetism and about the rules between ampere and between the voltage, and yeah, he called it dielectric displacements and flux density, and so definitely a theoretical idea. And the last one on my list of unknown physicists is a physicist, and he is known, and his name is Thomas Townsend Brown. The last one, maybe the most interesting, no, not the most, maybe one of the most interesting. Thomas Townsend Brown was an experimental physicist working again on capacitors, on asymmetrical capacitors, and he is the grandfather of the lifter, I guess. I don't know, I can't explain this what he actually did, but it resulted in having a lifter, and a lifter would be, so you have a plus wire and you have a minus plate, and you charge them with high voltages, with really high voltages, like 100,000 volt. And what happens is that the place with the most curvature, which if we watch this from a side view, we have a wire, this is the wire from the side, this is the wire, and we have a plate. So a plate, this is the minus plate, this is the plus wire. What actually happens is that there is a field. This field goes from here to there, and of course in the mirror on the other side. And it is the curvature here. And for some reason, whenever something looks like it doesn't matter if you have plus or minus on the wire or on the plate, but whenever you have something like this, it will try to get itself in that direction. On the internet, they say this is ionization of particles around the wire, so air particles here will all be charged and will all flow in that direction. I don't know what actually happens, but they say that this is what happens, ionization of air particles, and because it is ionized, the charge will let the particles move in a certain direction. I think that's going to be enough for today, because I've been talking way too long right now. Be sure to check out this list of guys. Maybe you want me to go in more depth of one of these guys. You can check them out yourself. They were an inspiration to me. This episode wasn't really about mathematics. It was more of my inspirations in the old days. These guys definitely inspired me to really get serious on the idea of having an Æther. Maybe it's interesting for you guys to check out as well. So yeah, thanks a lot for watching. If you like this video, be sure to like it. And if you have any questions or comments, leave them in the comments below. See you next time.